All right, what we're looking at is an actual write-up. Okay, Karina has, from period 5, has agreed to let us grade hers in front of an audience and to even record it. So, here we go. Your write-up will be formal. Oh, this is the rubric. Wow, something happened to it. Detailed rubric. Oh, you got these out of order. That's all. Okay, this guy should be your first page. Okay, and this is your second page. Okay, I'm not going to take points off on that right now. Okay, so excuse me, folks. All that Maya is going to do is what I'm going to show you right now. Okay, she's going to first of all look to see if this rubric is here, and it obviously is. So we're going to go ahead and give her 1 point, only she'll be marking over here, and it will be in pen. I'm marking in pencil, so if you want to keep the same page, you can just erase. Okay, do we have the purpose? Okay, the purpose is here. Okay, that means 1 point. Do we have the materials? Yes. Okay, and these, okay, where did we get these from? Where did they come from? Okay, Karina, where did you get them from? Shh. Is all of this is being picked up, as I showed in my other video, directly from the lab sheet online. Okay, and you want to be sure that when you do the lab sheet online, that you're going to get the actual HTML version by using the printer icon instead of the PDF icon. The PDF icon will not take over your tables properly. I found that out in first period, and I had forgotten about that. It just won't do taking it from a PDF file. So take the other one. It has a little printer icon, and that will work for doing the purpose, materials, chemical reactions, and then the observations, of course, are going to be yours. But right here, before observations, we should have something else. Okay, yeah. Who mixed it up? The Google Docs?
No, like, if I, did 4 and then 5, I would do it, half.
It's okay. Okay, it needs to be in order. Okay, so it would look as if, you would be graded as not having it. Okay, so we got the chemical reactions. They're good. And now we're looking for a procedure, not observations. Okay, so you essentially had printed you'd printed this guy before, and you wanted to just physically make it part of the document instead of electronically. And that's why you had this. Okay? So you need to fix that. All right? So I would take off a minor point deduction for that, and this is 10 points. I'd make it 8. Put it in order. Okay? And it's good to have these notes here so you remember what it is I was asking you to do. Okay, so also, if you will notice in Google Docs, they have up at the top of the screen, I was just working with this with someone at lunch, and at the top of the screen in Google Docs, if you will highlight this area right here in your table, you will find that there is a setting up there that moves things. You highlight it, you'll see one that's like a little dash line, and you just grab that thing with these 3 things highlighted, and it will move all of this over. And then it has a little hat thing, the thing that looks like this. And that thing will pull these guys back. so they line up properly. So just do a little bit better on the, because Google Docs will do that for you. You just have to look at the screen and watch for that. Okay, I wish I had made a recording of that particular situation. It would have been great. But so this just needs to be cleaned up a little bit, but still it's all on one page, so that would be fine. And this is all on one page, so that would be fine, but we want to get it in the right order. Okay? And so observations are next, and let's see how you did on observations. This is the place where most people take it in the neck. Okay? So temperature. Good. When the solutions were mixed, one corner of the bag became very hot. A perfect observation. Excellent. Okay? I had people say that it went exothermic. Well, that's a conclusion. That came from an exothermic reaction. Okay? And we can verify that the temperature rose, and then in your conclusion section, you would say, I had an exothermic reaction going on because I could feel the temperature going up. And that's cited in your observations. So that's perfect. So far, so good. Gas formation. Some gas was formed after all the solutions were mixed and approximately less than... Oh, okay. So this was your final weight. That came from your data table. Now, where's your data table? Is it down below these observations? Yeah, okay. I think in my other video I suggested that you do it this way, the data table second. And that's okay. But that's going to be referring to here. And you can see in your data table the decrease in weight. And that's, folks, would you make a note for yourselves, and especially those of you watching on video at home? It's important for you to, when you're doing this, make sure that you know the difference between observation and conclusion. We conclude that it's an exothermic reaction going on because it does get warmer. We conclude there's an endothermic reaction because it does get cooler. And if we look back at our reactions, okay, which we just copied in, we can see that one of these things is exo and the other's endo. Okay, so that's how you tie it all together in your conclusions. So temperature, excellent. Gas formation. Now you got to say something different. We had gas formed is a conclusion. Actually, you're looking at it. What are the signs? What's the observation that you saw that told you there was gas formation? Some gas was formed after all solutions were mixed. See, you're not telling me what you saw. Okay? In Rutherford's experiment that we saw, that we were looking at his conclusions on the animation. That is what he saw. Or that is not what he saw. What he saw was that little theater in the round thing on page, what is it, 95? Okay, I think it's page 95. And that's where we had the little box that had the lead shielding, and it had an opening. They opened it up. Alpha particles came shooting through, and they went through. 99% of them went through the gold foil, but some of them came shooting straight back, and all variations. To the side, to a little deflection, so they'd come in like this and just go a little like that, or some of them were just coming back, or like that. So there was all kinds of variations on that. That was the observation. That is what we would see if his thing is right. And his thing came from the observation. He was explaining the only possibility is there has to be a nucleus that is positive and weighs a bunch. In fact, it weighs most of the mass of the atom. And now, for this one, to say gas formation and observations, you'd want to stay away from that. You could say bubbles. We saw bubbles. Dead giveaway. You got a guess, right? What else did we see that told us we had a gas?
Plastic bag.
Plastic bag got bigger. Sure. That can only happen with a gas. And we're certainly not pumping any in. We have a closed bag, right? Okay? So this takes getting used to. So it's a good thing that we're doing this. It'll help everyone. Okay. Change or lack of change of mass for the bag with everything inside before and after the reaction. The mass before the reaction, after the reaction, okay, you're stating your stuff from your data table, which is a good thing to do in your observations. So the mass number has a specific meaning. No, okay, you want to say the mass. Leave out the word number, okay? Yeah, just take that out. Dropped approximately 1.47 grams. So now, one of the things you need to explain in your conclusion is, why did it drop? What was part of the procedure that we followed that could have caused a change like that to happen? Because we know the conservation of mass says nothing's created, nothing's destroyed, and our experiments are not going to disprove that. But we could look at the equipment, we could look at the way that we did the lab. For instance, how many of you had a situation where you put in the phenol red on top of the calcium chloride, the little beads, white beads? You put the phenol red in there, and it turned hot, right? Got hot, real hot, okay? That is an observation, okay? The next part of that was, how many of you had the phenol red solution turn yellow on you before you did the mixing? Yeah, okay. That means that you had some sodium bicarbonate on the inside of the bag. You didn't get your sodium bicarb all the way down into the corner before you released it. And so when you poured in your phenol red, what happened was you started the reaction. You could use that as part of your explanation, now that you know, okay? So, change or lack of change of mass of the bag and everything inside. The mass before and after. Okay, so you're indicating the change. And I like your highlighting the way you did this. It's very clear when you're reading it. Maya will love you for it. Okay, color and texture of chemicals. Before the reaction, this is very, very nice. I like the way this is written. Okay, so I'm good on those observations. And so every change that indicated a chemical change, gas form. Oh, nice. Okay, gas formation. Now this needs to be in your conclusion. Okay, did you have it in your conclusion? Okay, well, we'll get to that. Now I'm going to be looking for, do we have 3 decimals on all masses? And I'm looking at this and saying, wow, that's amazing. She got exactly 25 grams. Now this is the, oh, that's the mass of it. Okay, and then the volume you've got here, you would get off for that. Okay, the mass still has to have 3 decimals. 3 decimals, minus 1. And here, you don't have enough decimals. This should be 2 decimals. So I hope you can recover that. Okay? And then here, our masses have 3, and we're all good there. So I would only take 2 points off of this for the observations. And by the way, while we're here, I'm going to look at the 10-step procedure. 10-step procedure is here. It has a grade on it, and that's an automatic 10 points here. Okay, so this is going to be 10. The conclusion. Now, this is the one where everybody bites the dust. Or most people bite the dust. We'll see how you do.
It's really short.
Oh, yeah. Okay, but yeah, you're going to bite the dust then. Conclusion.